Hey everybody, this is the first lesson for Handout 1-1. I'm going to be going through the notes for this lesson. And the way to make this video the most effective that it could possibly be for you is to actually print out a clean copy of the notes before you watch the rest of this video. I know some of you may not have that capability, and that's okay. But if you do have the ability to print a copy, here's what you should be printing right here. Handout 1-1 notes. I've posted them in Canvas. Okay, so if you're able to print them and you haven't, pause this video right now, go print them, and then come back. All right, I'm going to assume that if you're able to have a copy of these notes in front of you, that you have one right now. And I'm going to proceed. Now, the other best way to take advantage of this video is to actually try your best to work through all of these problems without watching me do them first. This is what I would do if we were in class. I would give this handout to everybody. I'd have everybody sitting in groups of 3 or 4, and I would say, try all of these on your own. Feel free to talk to each other, compare your answers, see what you can remember, see if you can offer or receive help from somebody, and then we'll go through them as a class. It's so much better, okay? Listen to me. It's so much better if you try all of this stuff first and then watch me go through my approach to doing these things. It's better. It's better even if you're unsure. It's especially better if you're unsure of what you're doing as you're doing it. Okay. And it's even better if you look at it and you have no idea, but you at least you think about it to see if you have some idea, and then you decide, yeah, I don't remember how to do this at all. Okay. But it's better for you if you think about it and try it first. Okay. Because then when I go through it, especially if you've made a mistake and then you see how I fix it, you will learn better the right way to approach these problems, the way to do them correctly, than if you didn't try at all and you just watched me do it. Okay. So again, if you have a printed copy in front of you, or even if you don't, you can bring up, well, no, you can't. But if you have a printed copy in front of you, try them. Try all of these problems. Pause the video, try the problems, then resume the video. Okay. If you don't have a printed copy in front of you, here's what I'm going to do. I'm going to suggest you pause the video right now and just try there on your screen right now. Just imagine what you might do trying to graph this problem on this grid. Now, notice the instruction says, make a table only if it helps you to graph the line. When you learned how to graph an equation like this in first year algebra, you learned how to do it by making a table of values and then transferring the ordered pairs into points and then finally drawing a line through all of the points. But at some point, you got so good at graphing lines like this that your teacher probably didn't expect you to make a table anymore. And I certainly will not expect anyone to make a table of values. Okay. I'm not interested in seeing that anymore. My expectation is that when we come around to doing a quiz on this material, I give you an equation like this and a graph like this, that you're not going to have to make a table of values. I mean, you can if you want to, but I'm certainly not going to expect anyone to. And I will give full credit for everyone who can just draw the line without making the table. Okay. So once again, pause the video, think about working on this right there on your screen. Maybe, put your finger on your screen and say, well, I'd put a point here, I'd put a point there, and then I'd draw a line there and then resume the video. All right, so moving ahead, if we make a table of values, you just choose some random values for X. There's no negative there, although it's advisable to choose a couple of negatives and a couple of positives. You don't have to, but that's always a good idea. People like to work with whole numbers, but of course, you don't have to choose whole numbers either. They're just generally easier to work with. So if I put in -2 for x, -2 times 4 is -8. -1 times 4 is -4. 0 times 4 is 0. 1 times 4 is 4. And 2 in for x times 4 is 8. Now I've got a bunch of ordered pairs that I can plot. -2, -8. It doesn't quite fit in this grid. -1, -4 does. 0, 0 does. 1, 4 does, and then 2, 8 would be up there. All right, well, this is turning out to be a straight line, and you don't need any more than 2 accurately placed points to know where the whole line is. So the fact that I don't have room to plot the other 2 is not a problem. I've got 3 accurately placed points on here. Okay, but if I want to graph the line, I want to graph all the solutions represented by this line, these 3 are not all the solutions. To graph all of them, I have to draw a continuous, unbroken line through those 3 points. And of course, put arrows on the ends to indicate to the reader that this line goes off forever in both directions like that. Okay. Now that's the long way of doing it, in my opinion, making a table and a collection of ordered pairs. The quick way to do this, which I'm sure many of you remember, is to realize that any linear equation in the form y equals mx plus b, something times x, and then plus some other number, this number here represents, what does it represent? Do you remember? The y-intercept of the line, right? And what does that m value represent? Do you remember? The slope of the line, right? Well, this doesn't seem to have a b value at the end of it, but it does. You just have to use your imagination and think of it as a plus 0. So we could have graphed this line much more quickly by going right to the y-intercept of 0 and plotting a point there. And then using the slope value of 4, recall that slopes can always be written as fractions, and there's the fraction that's equal to 4. And the numerator represents the rise, the denominator represents the run. So from 0, 0, I would go up 4, 1, 2, 3, 4, and 1 to the right, and there would be my second point. And again, you only need 2 accurately placed points to draw the whole line. So once I have that point placed and that point placed, I could draw a line through those 2 points, put an arrow there and an arrow there, and that would be fine with me. Perhaps some of your algebra teachers insisted that you plot as many points on the grid as you could accurately fit. I'm not going to insist on that. If you have 2 accurately placed points, that is good enough for me. And then just draw a line passing through those 2 points, extending a little bit beyond them, put arrows at the ends, and you're all set. Okay? How about this second one here? Do you want to pause the video and try this? Go ahead. All right. So now we're back, and I'm going to use the y equals mx plus b approach to this rather than making a table. So again, the y-intercept is 0. So I'm going to have a point right there at 0 on the y-axis. Now, is there a slope for this or is there not? And what is the actual slope value? It's -1. Again, you've got to imagine that there's a 1 in front of that x. And the equation might look like this, -1x plus 0. And again, you got to imagine that slope value as a fraction, -1 over 1. Okay, so the rise in this case is not actually a rise, but it is a fall. From 0, 0, we're going to go down 1 because of the -1, and then 1 to the right. So there's the next point. Okay. And I got room for plotting a whole lot more points on this grid, and they would all be down 1 over 1, down 1 over 1, and up 1 over 1, up 1 over 1. But 2 points is good enough for me. Okay, put a line through them, put the arrows on the ends, you're done. All right. Now, if you're going to make this line longer, here's what I don't want you to do. I will take credit off for this. If you plot 2 good points like that, I'm going to erase that line there, and then you do this. Okay, wow, is that a really bad, sloppy line? If you're going to make it longer, you better make it go through all of these points accurately. Okay? The line you've drawn is missing all of these points that it should clearly be going through. I'm going to take credit off for that for being really sloppy. Okay? I mean, the easy way to do this problem, save yourself the work, don't make a risk, is just keep your drawing relatively short. Just make it go through only the points that you accurately plotted, and I'll be fine with that. Okay? All right, next one. You want to pause the video and give this one a try? Go ahead. All right. Now, this one's a little different. It's importantly different from that one. Where's the x in this equation? Where is it? It's like not there. But again, you might be helped by using your imagination and writing 0x minus 1. Okay? This minus 1 is the y-intercept. It's not the slope, it's the y-intercept. So on the y-axis, we have to go to -1 and put a point there. And now the slope is a slope of 0, which can be written as a fraction. 0 over 1 is the same value as 0. And so the rise is 0 and the run is 1. How do we interpret that? How do we apply that? Well, from this point, I would go up 0. That means I'm not going up or down. And then 1 to the right. There's the next point on this line. And again, once you've got 2 good points, that's all you need. Put a line through them, put arrows on the ends, you're done. This turns out to be a horizontal line. Any equation that is y equals a number turns out to be a horizontal line. And I know a lot of students remember that, but I also know that when it comes to quiz time, a lot of students will see y equals something, and they'll think in their heads, ooh, y. The y-axis is this vertical line here. So this equation must represent a vertical line. And they'll put a point on -1 there, and they'll draw a vertical line. And that is completely incorrect. Okay? If we had an equation that said x equals -1, that would end up being a vertical line. Okay? Which I know, again, some kids get confused on because they see x equals and they're thinking x-axis, horizontal. But think about all the ordered pairs that would make this equation true. -1, 0, -1, 1, -1, 2. See, the y values can change as long as the x value has to be -1 every time. So -1, 0, -1, 1, -1, 2. This turns out to be a vertical line. Okay? This is one of the kinds of equations that I most commonly see students make mistakes on, and that's why I'm spending so much time on it. I mean, it's easy to draw an answer for an equation like this. Everybody draws an answer very quickly. It's not as easy to draw the correct answer. Okay? Finally, here's an equation where the y-intercept and the slope are both very obvious to us. Okay, and so this is the kind of equation that students will answer correctly almost 100% of the time. So we go to +4, 1, 2, 3, 4, and then a slope of -2/3. Even when I quiz on this, even after students have been through a whole year of algebra, I will still see some students graph the slope incorrectly. -2/3. That is, if it's a negative number, the slope of the line is negative. The line must be going down from left to right, not up from left to right, but down. You can think of this as -2 divided by 3. Okay, only one of these numbers can be negative for the entire fraction value to be negative, because a negative divided by a positive is negative, or a positive divided by a negative is negative. But if we think of it this way, from this point, we're going to go down 2 and then 3 to the right. And I got room for another point there and another point over there, but you don't have to do that. Just put your line through those 2 points, put arrows on the end, and you're good as far as I'm concerned. Okay? Let's go to the back page. Again, I would ask students to do this, come up with their answers, talk about them in groups. I'm sorry, this wire keeps getting in the way. I'm going to try to do something about that on my next video. But I would ask students to do this in groups, talk about their answers, try to, help each other fix things and stuff. So pause this video if you can. And even if you don't have a printed copy of this, write down what you think the correct equations are for these lines just on a piece of scratch paper. All right, do that now. All right, I'm going to assume you're back. Let's take line A. Okay, this has a y-intercept of -4. And what is the slope? Well, from this point to this point, it's up 2 and 3 to the right. It's a positive slope because the line is going up. So again, if we're thinking of writing all of our equations in this form, y equals mx plus b, for line A, really got to do something about that next time. For line A, the y-intercept was -4. The slope was 2/3, so 2/3 x minus 4. Okay. On quizzes, I have seen in the past that students will write this. They'll write y equals 2/3 minus 4. Now, that might just be a little bit of carelessness, forgetting the x. But if you do not write the x, I will mark it wrong because it is wrong. Okay. There are certain kinds of carelessness that I feel like I can overlook, and other kinds that I feel like I cannot, I should not. If you forget the x there, it's going to get marked wrong. I've seen it many times. All right, so be careful. Also, I get students asking this: is it okay if I write 2/3 x plus a -4? Do you hear that heavy sigh coming out of my mouth? Okay. Yes, it's okay, because technically this is accurate. But here's my opinion on that. That is junior high, okay? That's a junior high way, middle school way of writing an equation. You're in high school now. You should never be writing plus a -4 anymore. I mean, it makes you look like you're still in middle school, because real mathematicians never write stuff like that anymore. Okay? So please get out of that habit if you're still in that habit. Just because I want you to look more mature. I want you to look like you're grown up. Okay? So y equals 2/3 x minus 4 is how I would prefer to see you write it. I won't mark this wrong. I want you to stop doing it. Okay? Line B. The y-intercept is 0. Okay? And the slope from this point to this point is down 1 and then 4 units to right. It's a negative slope. The line is going down. So y equals -1/4 x. And then the y-intercept is 0. So do you write plus 0? Well, you can, and I will mark that correct. But this is another example of something that students write that I let out a big sigh and I go, really? Come on. You don't have to write the plus 0. What is the point of writing the plus 0? And again, I get it. Maybe your algebra teacher wanted you to write the plus 0 to communicate that you clearly understood that the y-intercept was 0. I'd rather you not write that anymore. Okay? Just y equals -1/4 x. That is the more simplified version of the equation of this line. Line C. All right, there is no y-intercept. It's a perfectly vertical line. All right, that's one of those equations, and it's going through what, -5? Well, it's either y equals -5 or it's x equals -5. And again, a lot of students feel like they're guessing, like they can't ever remember. Should it be y equals or x equals? Okay, well, I'm just going to answer this one. It should be x equals. And if you want to understand that, rewind this video about 10 minutes or maybe 5 minutes to the front side where I was talking about graphing an equation that said y equals -1. Go back and replay that part of the video. Okay, line D. Ooh, this one's not showing the y-intercept. And you're going to need it to write the equation of this line. Well, we can find it pretty easily. From this point to this point is down 1 and 3 to the left. So go down 1 and another 3 to the left. There's your y-intercept, okay, which is +4. What's the slope of this line? From here, it's up 1 and 3 to the right. Once again, this line is going up from left to right. It must be a positive slope. We never think about the slope going to the left. I know this line goes down when it's going to the left, but we never read lines to the left. We always read them left to right, just like we read print. We always read left to right. And left to right, this line is going up. It is a positive slope of 1/3. So y equals 1/3, and then a y-intercept of +4. Hey, did you see that mistake I just made? Don't make that mistake or I'll mark it wrong. Last line, E. Again, we got to find the y-intercept here. Let's see, down 2 and over 3, down 2 and over 1, 2, 3. Uh-oh, that is not a simple y-intercept. It's surely not a whole number. Okay. That's a trickier one. That's one we're going to work on a little more going forward. But I want you to be able to come up with that exact y-intercept. I don't want you to guess. I don't want you to just sort of write, well, 2.5 because it's in between 2 and 3. Or guess maybe 2.6 or 2. I want you to get it exactly. Okay? So how do we get it exactly? Well, there's a number of ways to do it. I'm going to recommend this way, not insist. I'm just going to recommend that you recall for yourself that this line is going to fit this form, okay? And we know what the slope of this line is from these 2 points. It's down 2 over 3. It's negative because the line is going down. So you put -2/3 in for the slope, okay? Now you got to plug in an ordered pair for the x and the y. Either plug in these coordinates here or those coordinates there. It doesn't matter. Pick any point on the line that you want. I'll pick this one. -2 for x, +4 for y, and plug those in. -2 for x, +4 for y. Put the equal sign there, put the +b there, and now look, you've got an equation with only one variable in it. It's going to be pretty easily solved. I'll show you the steps, and then we'll know what the y-intercept is. Then we can write the whole equation of the line. Okay. So what is -2/3 times -2? Well, a lot of people would like to change that -2 into a -2 over 1, okay, plus b, because then they'll know how to multiply these two numbers. Now I've got two fractions, and we multiply fractions by multiplying straight across. Numerator times numerator, denominator times denominator. So 2 times 2 is 4. 3 times 1 is 3. I'm going to get 4/3, and a negative number times a negative number is a positive. So this all turns out to be 4/3 plus b. Okay, now how do I solve for b? Well, I've got to subtract 4/3 from both sides. Please do not turn this into 1.3. That is not the same number. If you want to turn it into 1.3 repeating, and then subtract 1.3 repeating from both sides, then you would get 2.6 repeating over here. Okay. But I don't want anybody throwing away decimal places. This is advanced geometry, and I want exact answers whenever you can give them. In regular geometry, I might let students get away with rounding, throwing off decimal places, but not in this class, okay? So here's how I would do it, literally in my head or on paper. I would subtract 4/3 from both sides like this. I would not turn this into a decimal. Okay. But how do you do this? How do you do 4 minus 4/3? Again, I know I'm pretty good at this in my head, but I'll show you on paper. I would change this whole number into a number of thirds. How do you do that? By multiplying it by 3/3. This is the number 1, isn't it? 3 divided by 3 is the same thing as 1. Okay. And 4 is the same thing as 4/1. Now I would multiply those two fractions straight across. 4 times 3 is 12, and 1 times 3 is 3. 4 is the same as 12/3. I'm sure a lot of you do not have to go through this written work to turn 4 into 12/3. But if you do need to go through this written work, then do it. Okay? So 12/3 minus 4/3. See, that's something that's pretty easily done in your head. 12 minus 4 is 8. Okay, and the denominator, of course, stays the same when you're adding or subtracting fractions. So 8/3 is the b value. And now I can write my final equation as y equals negative 2/3 x plus 8/3. And can I say again, there is absolutely no good reason to turn this into a decimal number. And I'm going to give you, I'm going to elaborate on this, okay? Because I really want you to stop turning your fractions into decimals. Fractions are fine in your answers. I want you to hear me say that again. Fractions are fine. Because here's what students will do. They will pick up the calculator to turn this into a decimal, and maybe they'll hit the wrong buttons on their calculator, and they'll get a wrong decimal value, which is foolish because you had a correct fractional value. Now you've got an incorrect decimal value because you just accidentally hit the wrong button. Or they'll do this. They'll put the right buttons in. They'll get 2.66666666 on their calculator, and then they'll write y equals negative 2/3 x plus 2.6. And I will mark that wrong because it's not exact. Okay, they threw away all of these sixes. Okay, or some students will say, oh, you mean you want us to, we should round that up, right? Because it's 6/6, so that should round up to a 0.7. No, still wrong. This is not the same value as this. It's not exactly this. Okay, now, if you want to write 2.6 with the line over it, okay, now that's correct. But really, why waste your time reaching for the calculator, turning this into a decimal and writing this when you could just write down 8/3? Please, please, my advanced geometry students, get comfortable, more comfortable with fractions. They're perfectly good numbers. Okay? My only stipulation, my only requirement about writing down fractions is that they should always be reduced as much as possible. Like, you should never write down 10 halves, okay? 10 halves is not reduced. You should turn that into a 5. You should never write down 12 eighths as a fraction, because that's not reduced. That could be reduced to, both of these are divisible by 4, 3 halves. That's the reduced form. But when I say reduced, I do not mean turn it into a decimal. That's not reducing a fraction, okay? That's changing the form of the number. And by reduced, for goodness sakes, I definitely don't mean turn this into 2 2/3. I hate mixed numbers. I don't really hate mixed numbers. I just hate how confusing mixed numbers are for my students to do arithmetic with. That's what I hate. And so don't waste your time turning this into a mixed number or a decimal. Leave it like it is. That's the answer I would like to see. This is an answer that certainly would get marked correct. And I would mark this correct also. But gosh, I hope you all will stop writing mixed numbers in your answers. It's a total waste of time to turn a perfectly good number like this into a mixed number like that. Okay? All right. So now, again, if you can print off a copy of the homework to do, print it off and work through it. And if you can't print off a copy, just as best you can, do your work on regular notebook paper, and we'll see you in class.